we're having a look at the 2013 Maths Methods Exam 2 and the multiple choice questions, okay? And we're going to do questions 1 to 11 in this video, which will be part 1, and then we'll do the balance of the questions up to question 22 in part 2, okay? So let's get underway. Okay, question 1. The function with rule f of x equals minus 3 tan 2 pi x has period. Which one is the correct answer? Okay, you have a shot, come back. You know that if y equals tan of nx, then the period is pi over n. Okay, so we can work it out from that little formula there. If the period above is pi over 2 pi, okay, where 2 pi is the n term, that will be 1/2. Therefore the period is a half, therefore the answer is C. Okay, question 2, the midpoint of the line segment that joins those 2 points is, you have a go, come back. Okay, it is just the average of those 2 points, so you add the x coordinates together, divide by 2, you get 1 plus d over 2. You'd add the y coordinates together and divide by 2, and as follows, the midpoint is 1 plus d over 2 for the x coordinate, and minus 5 plus 2 over 2 for the y coordinate, which would be 1 plus d over 2 for the x and minus 3 over 2 for the y, and that's option A. Okay? Question 3. If x plus a is a factor of 7x cubed plus 9x squared minus 5ax, where a is a real number with the exception of 0, any real number with the exception of 0, then the value of a is. Now, guys, with these technology-enabled exams, you've got to make up your mind which is the quickest, most efficient way to do these questions, because you've only got 1 minute and 40 seconds for each of the 22 multiple choice questions if you're not going to run over time. Now, I think in this case, the easiest thing to do would be go straight for the CAS, as I will show you here. What I've done there is I've plugged the function in, called it f1 of x, into the calculator. Then I've simply said solve for f1 of negative a, because if x plus a is a factor, then minus a is a root. Okay, so f1 of negative a equals 0. Solving it for a, you get these two answers as possibles, but they say that it can't be 0, so therefore your answer is 2. That would take you about maybe 30-40 seconds to do that, and you've got the answer. If you decide to do it manually, I think it's a little bit more dodgy. I wouldn't be doing that, but here's a way of doing it. You can factorise it manually, you'll get that. Okay, then if you try and factorise this bit here, that's in the bracket there, equals that. Okay, equals that. So therefore, if we are expanding the, say for example, the x term of the right hand side, you could then equate that to the coefficient. You could find out what its coefficient is and then equate it to the coefficient of this term here. So expanding this, you'll get an x term, you'll get 7ax there, you'll get minus 5x there. Okay, therefore what you can say, therefore, yes, that equals that. And now we've got a coefficient, 7a minus 5x. Over here you've got 9x, and therefore, equating the left-hand side and the right-hand side, you can say 9x equals 7a minus 5x, therefore 7a minus 5 equals 9, therefore 7a equals 14 and a equals 2. There's your answer. I think that would take considerably longer than the CAS option, so I'd be going for CAS in the first instance every time with a question like that. Okay, so the answer's E. Okay, question 4. Have a look. We've got part of the graph of y equals f of x, where f of x equals 3 minus e to the x. That's minus e to the x plus 3, vertical translation of 3. So this is the one, okay, as shown below. Okay, now what have we got to do? Which of the following could be the graph of the inverse function of f? Okay, you have a go, come back. Alright, these are always really, can be very confusing when you're trying to get the spatial geometry of the whole thing of the inverse sorted out. So what I would advocate in the first instance is just grab a few reference points and swap x and y. In this case, the y-intercept is 0 and 2, and we've got an asymptote there of y equals 3. So that would mean that for the inverse we've got an asymptote of x equals 3 instead of y equals 3. We'd also have an x-intercept of 2 and 0, and the only one that qualifies in that is e. Now, if you're quick off the mark, you could do that in less than 30 seconds, okay? So that's why you need a lot of practice to get good at these, alright? Okay, question 5. We've got, if a function going from minus infinity to plus 1 not inclusive maps to their real y values, where the function is 2 times the natural log of 1 minus x, and g goes from minus 1 including minus 1 up to positive infinity, where g of x equals 3 times the square root of x plus 1, then the maximal domain of the function f plus g. That's an addition of ordinates thing, but it only works, guys, for the domain which is in common to both. Okay? Now, if you're in any way confused by these things, you need to draw a very quick number line. That's what I would do there. Now, we've got f of x, okay? The domain of f of x goes from minus infinity to 1, not including the 1. The domain of g of x goes from 1, including the 1, up to positive infinity. And the overlap is what you're interested in, where both of these things, both of these lines, these red lines, overlap, and the values of x for which that is the case. Okay? So you have a look and see what you think. Yes, the maximal domain is the intersection of both of them, which is going to be from minus 1 including minus 1 up to but not including 1. So therefore the answer is A. Okay? Very good. Alright, next question. Question 6. For the function f of x equals sine 2 pi x plus 2x, the average rate of change. Okay, average rate of change. You've got to know how to do those. With respect to x over the interval from 1/4 to 5 inclusive is. Well, guys, you could probably do that manually, or you could do it on the CAS. You'd have to type this in to your CAS device as a function, and then you'd have to just go f of 5 minus f of 1/4 all over 5 minus 1/4, because the average change of anything is just y2 minus y1 over x2 minus x1, okay, for a function of y in terms of x. So I've done this one manually just to show you what to do, but I would think that it would be a bit of 6 of one and half a dozen of the other as to which is quicker, the manual or the CAS technique. But this is what you do. There it is. So that's sine of 10 pi plus 10 minus sine of pi on 2 plus a half all over 5 minus 1/4, which is 19 over 4. It's getting a bit messy. These are pretty easy to work out though. This is going to be 0. That's going to be 1. So if you're okay at your mental arithmetic, go for it. Otherwise, just hit the CAS, guys. Just hit the CAS, and it'll come up for you very easily. The answer looks like 34 over 19. Option B is for you and me. Okay, that's that one done. Alright, they're getting harder. Now this one here, if you have a look at this, it does your head in a bit. So you just play it cool, take a deep breath, and just think, no, I can do this, I can do this. Now, what do we got? We've got a function such that from minus a to plus a inclusive maps to their associated y values, where the function is the sine of 2 times x minus pi over 6. This function has an inverse function, which means it's got to be 1 to 1, guys, 1 to 1. And as you know, sine is not 1 to 1, it wobbles all over the place. So we've got to pick a 1 to 1 section of it, right? And that's what this is all about, okay? Now, the maximum possible value of A. Oh my goodness. Yes, you think, Well, don't panic. You've got to pick. You've got to pick an up section or a down section of this sine curve, all right? Because they're the only they're the only bits that have 1 to 1, and we've just got to figure out what's going on here. Think about it. Now, this function here is a natural starting point. It's been shifted to the right by pi on 6, right? Its natural starting point, which would normally be where x is 0, is now at x is pi on 6. It has a period of pi. Okay, now as you know, sine shifts around in quarter cycle ups and quarter cycle downs, if you know what I'm saying. Let's split it up into 4 bits, okay? Normally goes up to pi on 2, then down to pi, then down some more to 3 pi on 2, then up again to 2 pi. So think about this. Now, this is straddling the y-axis, right, from minus a to plus a. So we've got to go, let's go backwards from pi on 6 for a quarter of a cycle. Now, that would take us, a quarter of a cycle would be pi on 4, wouldn't it, I think? Yeah, pi on 4 backwards takes us from pi on 6. If you go pi on 4 backwards, it takes you to minus pi on 12. Now, that is the point where it's reached its lowest point. Okay, and then it's going to start tracking back up again, which is no good to us. So it reaches its lowest point at minus pi on 12, and then it proceeds up to this natural starting point where x is pi on 6. So let's just go through it again. Starting point is pi on 6, quarter cycle is pi on 4. For the inverse to exist, the function has to be 1 to 1 with a shape as shown there or there, okay? So far so good. Now, the section crossing the y-axis is going to have that shape, as I explained to you just a moment ago, where the lowest point occurs 1/4 of a cycle to the left of the starting point, alright? So therefore, this is where we have x equals pi on 6 minus pi on 4, which is minus pi on 12. So ladies and gentlemen, if you do a little visual of that and draw a little picture of it, you'll see that is the lowest point of the graph, okay? And it's to the left of the y-axis, which is where we want it. So therefore, I would say that A has to be minus pi on 12. So you'd be going from minus pi on 12 to plus pi on 12. So do you get me? And therefore A is the right option, okay? Quite difficult, but if you just chunk down bit by bit, it's not so hard. That one might take you a bit more than a minute to figure that one out if you're fast, okay? Okay guys, question 8. Now, Xenia travels to work. She either drives or takes the bus. If she takes the bus to work one day, the probability that she will take the bus to work the next day is 7/10. If she drives, on the other hand, to work one day, then the probability that she will drive to work the next day is 3/5. This is conditional probability. You can tell that by now. Assume that Xenia will always travel to work under these conditions. Yes, we get that. What is the long-term probability? Do you see that? Long-term probability, Markov chains, that Xenia will take the bus to work. Well, you've got to get a transition matrix happening here, guys. So let's do that. Okay, so we've got bus. So let's say today, this is the given up here, okay? Given bus or given drive, say yesterday. This can be bus or drive, say today. Okay, so that's bus today, given bus yesterday. This one here is drive today, given drive yesterday. You get that now? So let's fill in the numbers. The first thing is bus given bus. That was 7/10. Bus today, given that she took the bus yesterday, and therefore they have to add up to 1, so that's going to be 3/10. Okay, now the next clue is if she drives, that's drive, okay? That's a 3/5, so that's down here. 3/5 is down there, and therefore this one's got to be 2/5 because they've got to add up to 1. Okay, now let's work out what the next step is. Just don't rush in, just work out what to do, calm as a cucumber. What is the long-term probability that Xenia will take the bus to work? Now, alright, you can either do this by put this into your CAS and call it T for transition matrix, and then go T to the 50 times your initial state matrix, which it doesn't matter if it's, say, a 1 here and a naught there, or a naught there or a 1 there, because they both converge after you do, say, the number of transitions required to get steady state to, say, 4 decimal places at least. It doesn't matter whether your transition matrix is 0, 1 or 1, 0. However, guys, having said that, that is no good, absolutely no good in this instance, because these are all in exact form. So you've got to do the other way of working out the long-term probability, and that is basically you do this. you say, okay, my initial state matrix, I'll call it x and 1 minus x. I've called that S for initial state. Kaboom, right? Then I've put in my transition matrix here and called it T. Now, this is the way you do these exact form ones. You say solve for T times S equals S, and I'm solving it for X, okay? I'm solving it for X. In other words, when you've got to the steady state situation, if you transition it one more time, this S is the steady state situation, right? So therefore, if you transition it one more time, it doesn't make any difference because you're already at steady state. That is what you're doing, okay? And you're solving that for X, okay? You're solving it for X. This times this gives this, and X is the only variable in there, and it comes out to be 4/7. So therefore, your answer is C. Okay? That's what you do. Okay, question 9. Let's have a look. Harry is a soccer player who practices penalty kicks many times each day. Each time Harry takes a penalty kick, the probability that he scores a goal is 0.7. Okay, independent of any other penalty kick. That's a bit of vital information there. So this is not conditional probability, guys. These events are independent of each other, and it looks to me like he's got 0.7 of getting a goal, therefore 0.3 of not getting a goal. This has got to be either yes or no in terms of getting a goal. It looks like binomial to me. So, okay, so let's just tuck that one away. One day Harry took 20 penalty kicks, given that he scored at least 12 goals. Okay, this is a given. Okay, therefore, the probability that Harry scored exactly 15 goals, given that he scored at least 12, is closest to. Okay, well, you know the formula for that, don't you? I've given you a hint, so you have a go now, and you come back when you're ready. Okay? Okay, now, let x equal the number of goals. I always start off with that, so I sort of know what I'm doing. I've got it all sort of locked away, and now I can put it into the maths. Now, x follows the binomial distribution where we've got 20 penalty kicks, so the n is 20 and the probability of success is 0.7. Okay, now you know your multiplication rule, don't you? If you don't, you better go back and look at it. It's very important. Therefore, the probability of that x equals 15 given that it's greater than or equal to 12 is equal to the probability that x is equal to 15 and x is greater than or equal to 12 over the probability that x is greater than or equal to 12. Now, often this kind of thing up here just boils down to one of those two things. If one of them includes both, then you only need one of them in terms of logic. So I think you can see that if x is 15, that automatically means that it must be greater than or equal to 12. Don't you think so? Yes. But on the other hand, if x is greater than or equal to 12, it doesn't necessarily mean it's 15. So this is the one that covers both, if x is 15. So we can rewrite that formula like that. And now we can basically get straight onto the CAS and make short work of it. So the probability that x equals 15 is found on the TI at least, the one that we use at our school, TI CAS handheld. That's the binomial probability distribution with n is 20, probability of success is 0.7, and you've got 15 successes. The probability of that is that. Make sure you have your calculator on lots and lots and lots of decimal places. I would just go for float. Float should do it because it's very easy to get rounding errors with these kind of things. And secondly, the denominator bit, I'm using the binomial cumulative distribution function here with basically I'm saying I've got 20 tries, probability of success is 0.7, and I'm going from 12 to 20 inclusive, that is greater than or equal to 12, okay? Probability of that is this, and therefore 1 over the other. You see I didn't round off, did I? I just called down the answer to this, and then called down the answer to that, and just went for it, okay? So I'm not going to have any rounding errors here. That's 0.201725, which looks like number E. Okay, number E is our man. Okay, very, very good. How are you feeling? Yes, let's keep going. Alright, question 10. Okay, we've got some probability happening here. So events A and B, the probability of A and B is this, probability of not A and B is this, and the probability of A and not B is that. If A and B are independent, then the value of P is. Guys, to me this is definitely a Venn diagram or a Carnot map, whichever you prefer. Choose your poison. It's not really poison. I'm a Venn diagram man myself. I love visuals of everything. So first of all, we know that if A and B are independent, then the probability of A and B is PRA times PRB. That's the special case of the multiplication rule for independence. Okay? Now come on, let's go with the Venn diagram. Now, let's see if it makes sense. We've got probability of A and not B was 3p over 5. That's this bit here. There, round to there, round to there. Okay, 3p over 5. The probability of B and not A, that's this one. B and not A is p minus an eighth. So that's from here, round to here. Now that's exclusively B, in other words. And the A and not B was exclusively A, right around there, right there. The other thing they tell us is that the probability of A and B is P, so let's put that in. Okay? Now it's very, very easy for us now to construct, we want this times this, so it's very easy for us to work out what the total probability of A is. It's everything in the A circle. Okay? So it's P plus 3p over 5, and all that comes to 8p over 5, and also similarly, probability of B, that's all of the B circle, is now P plus P minus 1/8, okay, and that comes to that. Now we can work it out. We can multiply PRA by PRB and get PRA and B, and we'll substitute in. Therefore, that's, okay, PRA and B is P, that's PRA, that's PRB. Now, what we've got to do is find the value of P, which makes that equation work, okay? Yeah, you just have to basically multiply through by 5 and solve it for P. It's a quadratic, so it looks like, yes, it looks like 16p squared equals 6p. Therefore, solving that using the null factor law, we'd say P is 0 or 3/8. Now, this is the trick. They're both there. So only one of them can be right. Now, you've got to look back and you'll see that that makes perfect mathematical sense, but P is 0 makes absolutely no contextual sense, that is in the context of this situation, because if you went up here and made P 0, that'd be 0, that'd be 0, and this thing here would be minus an eighth. That's this B and not A. Well, that makes no sense. You can't have negative probability. So mathematically 0 works, but probability-wise it does not work at all, so therefore the answer is 3/8. So the answer is C for you and me. Okay, question 11. If the tangent to the graph y equals e to the ax, where a can't be 0, at x equals c, passes through the origin, then c is equal to one of these. Oh dear. Well, I think with some of these things, when you can't see clearly exactly what to do, you just make a start. So I would be starting off by taking the derivative of this and then substituting x as c in there, because that's what the gradient of the curve would be when x is c, and it will also therefore be the gradient of the tangent, okay, because that seems to be featuring in here. So let's just do that first and then just see where that takes us. So if y equals e to the ax, therefore dy dx equals a times e to the ax, and if you substitute x equals c, you'll get that. Now that is the gradient of the curve when x equals c, and therefore it's also the gradient of the tangent where x equals c, okay? Now, that's right, at the coordinates c and e to the ac. Right, now, this is the next bit. If the tangent passes through the origin, now we're using this bit of information here because we have to use that to get the problem out. We know that the gradient of that line joining this coordinate point here, c and e to the ac, to the origin, which is apparently the same as the tangent according to the question, then we can basically work out the gradient of that line, e.g. the gradient of the tangent in another way, okay? Another way. So we're just doing y2 minus y1 at the origin over x2, where x is c, minus x at the origin. That is also the gradient of the tangent, okay, expressed from a different clue in the question, okay? So therefore, we can just simplify that like that. Now, we've got two bits of information here about the gradient of the tangent. We've got this one and we've got this one, and they, of course, must equal each other, okay? So therefore, we can now solve that, and it looks to me like it's going to be very easy to solve because we can just cancel those terms on the left hand side and the right hand side, and therefore we're left with a is 1 over c, and we're trying to solve it for c, so therefore we can say that c is 1 over a. Hooray today, and that gets us b, Mr. B, okay? So that was the answer to that one. Now I think I would do that the manual way. I don't think I need CAS for that. And as I say to you, you'll get better at knowing how to do them with more and more practice. So I'll see you in part 2 of this video, when I will go through questions 12 to 22 inclusive for you, and feel free to go back and have another look and to have another go at them and get familiar with them, okay? Thanks for coming, and all the best.